Okay, in the last video we covered G1 and S phase, so I forgot to do this. In S phase, we, over on page 122, so fix that on your notes. It is not page whatever that was. On 122, we saw that this was a synthesis phase, which means to make, like photosynthesis. You're using light to make stuff, and that is where the DNA is made. We have brand new DNA is made. We get double the copies of DNA. We end up 2N. Okay, so I'm going to go ahead and put that. We're in here, and we end up as 2N here. Okay. And then the next phase over here is G2. G2 phase is once we've already doubled our DNA, like we are on the road to cell division, because there's no reason to do this. Like I said, you have a lot of DNA. You already have 6 feet of DNA in every single cell anyway as a human, and so you don't need double, but the only reason you're going to get double is if you get a signal. So G2 is we're getting ready to divide. So I kind of think about this one as like prep for surgery, because remember, DNA is like the brain of the cell. So you are about to do brain surgery on this cell. Okay, so G2, like I said, I kind of think about this as getting ready for surgery. And if you're going to go into surgery, you have to get still. Everything has to slow down. Everything needs to just kind of be chilled out. So the cell grows and gets ready to divide. The cell is going to grow a little bit more, and then it's going to start slowing down and chilling out a whole lot. So we're going to go back over here to page 124. Remember, we're 2N now. We've been through S. We're going to end at 2N on G2. But let me do my little magic trick again. It is not gap. We're just going to call it growth. It used to be called gap, like I said in the last video. So the cell prepares to divide. The cell must basically get put to sleep, because M phase is practically brain surgery. You're exposing the DNA. You want everything to be chilled out and calm for brain surgery. So when we end G2, everything's chilled in the cell. It is ready for either mitosis or meiosis. So I do want to point out that there's a lot of phases. I know there's a whole lot of words here. You've got interphase, metaphase, and then we're about to get into 4 more phases with the actual division. Then you've got these like G2. G1 and S. G1, S, and G2 are all called interphase. This is like the majority of the cell's life. This is the majority of the life of the cell, because this is where it's just doing its job, and we don't need, like, it's just, think about humans. The majority of a human's life, you're not reproducing. The majority of a woman's life, you're not pregnant. It's just a certain time of life. And so same thing here. This is just them living life. This is division. This is reproduction. This is the normal life, okay? So interphase, and I'm going to highlight that because it's yellow. I'm not going to use a highlighter. I'm going to use a yellow. Interphase is the longest phase. Because it consists of G1, S, and G2, and because it's just like the normal life of a cell. It's doing its job. It's doing its thing. G2 is the special, kind of like I say, extra phase that some non-dividing cells, like I said, if you're looking at nerve tissue or whatever, nervous cells, that they might enter once they're fully mature. Heart cells do it as well. Oh, I didn't mean to put cell, I meant to put heart. Heart cells, nerve cells, stuff like that, they do this to just their mature cells. They have a longer lifespan. But interphase is the longest phase of a cell cycle. So these three phases are in interphase. And then the last phase is M, and it is either mitosis, like we call that for somatic cells, or meiosis for gametes, which are sex cells, okay? So depending on which cell you're looking at, it will go through one of these two M phases. So when you open this up, they're both here. I really couldn't come up with a better way to do this. We're going to start with mitosis. Okay, so mitosis, we ended G2, kind of ignore this piece. We ended G2 with 2N, so we're going to begin mitosis with 2N. And then as we go through, we're going to eventually end up with two brand new cells that are both N. Okay, so these are our new cell. This is a new cell, and this is a new cell, and they'll both enter G1 individually, okay, at N. So there are 4 phases of mitosis, and I just remember PMAT. Okay, so if you'll just remember PMAT, that will help you remember the order of these phases. It begins with what we call prophase. If you'll remember, the word part pro means before, so just as this is the phase before all the other phases. Prophase, metaphase, anaphase, and telophase. And then there's also, like, now they're kind of looking at telophase having 2 parts. The last part is cyto, which means cell, kinesis, which means movement. So it's actually like the final separation of the 2 cells. So telophase is cytokinesis. We're going to have cytokinesis in our slides when we look at this individually, okay? And so if you're a body cell, this is what you go through. We go through this to heal, to grow, and just to replace dying cells. If it's a sex cell, we're going to go ahead and fill this out. We're going to talk about that. We're going to have 2 different videos for these. If it's a sex cell, we have to do all of those twice because, like I said in the last video or earlier this one, I can't remember, you're going to start off with 2N. But we do not want cells to be an N. We do not want a full set of chromosomes for a sex cell. We need half because we need the other sex cell to give the other half of the DNA. So we need cells that have half. So we have to go through division twice to get half N. So what we do here, I'm going to flip this around, we do PMAT twice. So I'm going to make this break a little bit bigger here, but we have prophase 1, metaphase 1, anaphase 1, and telophase 1. So by the time we do all this, which you'll understand when we talk about what happens during these phases, it's actually very simple, is you end up with 2 cells, but they have all of the DNA. We don't want that. We need them to have half of the DNA. So we have to start again. So after telophase 1, those 2 brand new cells will go straight into prophase 2. And then metaphase 2. Anaphase 2. And telophase 2. And at the end of telophase 2, you will have 4 haploid or half N cells. Okay? So that is, I think that is it on just the overall cell cycle. Now we're going to, on the next videos, we're going to get into the details of mitosis and meiosis. The last little thing I want to point out, and some of us cut it off and threw it away because it didn't fit on this, I do want you to understand, and we're just going to add it here. Some of y'all glued it over here to the side, but I'm going to write it right here. An uncontrolled cell cycle the cells have like these checkpoints, and they check and make sure the DNA is right. And they check and make sure that everything is set up. They check and make sure that everything's set up to divide and all this stuff. If there is some kind of issue where they are not being checked, and it is just zooming through the cell cycle over and over and over again, that is how we get tumor growth. And okay, so uncontrolled cell cycles, when it's just dividing, that is, luckily, that can cause tumors. And the reason I say luckily is cancer, we don't have any indication that there's anything wrong with the cell. Remember, all cancer is a mutated cell that is not acting right, and luckily, a lot of cancers create uncontrolled cell cycles. So they just keep reproducing cells. Cells have rules, like your skin. My crusty skin this morning, but your skin, if you have a cut somewhere, it's going to fill in the cut. I have a cut somewhere. I saw one yesterday. There we go. So I have this little spot right here on my wrist. It is going to heal. It's going through mitosis right now because to the cells around that spot, it is a huge gap, and it has to fill in with brand new cells. Cells have a rule. When you're touching another cell, stop dividing. You don't just divide for no reason. And so as long as there's not a need for division, they don't just, you would have skin just growing and you would just be dragging it behind you. So it will fill in this little spot and then it'll stop dividing at an abnormally fast rate. Uncontrolled cell cycles don't do that. So they form like masses of cells, and we call those tumors. So that is a good thing, because then that's an indicator that there is an issue. And so we can find it before it just takes over. So I just want you to know that if this goes out of control, that does form tumors. Okay, so the next video is going to be over mitosis, where we're going to learn about somatic body cell division.